So we're going to be giving a panel, and we're talking about making interop fast. And generally, this is going to be talking about different kinds of bridging, intents and preconfs, and how those things relate. So I'll go roughly down the panelists and noting we have a few changes from what is on the screen. But we have John from T1. We have Ismael from Lagrange. We have Robert from Union. Thank you for having a name tag. We have Dom from Interstate. And we have Mayur from Arcana network. I'm just going to go down the thing. If you could just give a really quick, like 30-second, 1-minute intro on who you are, what your project is, and also specifically like how it relates to Interop. Just kind of categorize yourself a little bit for the audience.
Hey, my name is John. I built Enigma and Secret Network. This was like first time TEs were used in production in our industry. Now I'm building T1. T1 is a TE-enabled rollup. And the way we come into the Interop game is we're also running different rollup full nodes in our TE infrastructure. So that allows us to basically read and write from and to different rollups. That's kind of how it does Interop.
Good. All right. There we go. All right. Well, my name is Ismael. I'm the founder of Lagrange Labs. We are a ZK company. Right? We're one of the larger ZK companies in the space. We focus on the generation of proofs in a decentralized manner, as well as fundamental research across a wide variety of areas in ZK, all the way from authenticated data structure design to verifiable SQL for things like ML and for things like co-processing.
Hello, hello, hello. Yes, hey, my name is Robert, head of research at Union. Union does interoperability, so we do bridging, and we do that in a trustless way via ZKPs.
Hi, hey everyone, my name is Dom, head of research at Interstate, filling in for the founder Irfan. Guys, you got double booked for another panel at the same time. At Interstate, we work at Preconfirmation sidecar for validators, currently running on a host key. Hopefully it's still going to be alive by the end of this talk. And if you're a validator or handling validators, just come talk to us, because running our sidecar is basically free money, and we're onboarding as much as we can. And obviously, as far as preconfs and the interop go, preconfs is a pretty big ingredient in the recipe.
Hey, I'm Mayur. I'm one of the founders at Arcana. At Arcana, we like to say that we are in the business of abstractions. We've done wallet abstraction, gas abstraction, and are currently doing chain abstraction. So our chain abstraction protocol that we built and is actually on testnet right now with a couple of products essentially unifies a user's asset balances across different chains and allows them to spend these unified balances as one on the apps that they like to use. So in that way is how we relate to Interop.
All right, thank you. So we are talking about Interop. We're talking about bridging. There's a lot of terms. Some of them are overloaded. I want to make sure we kind of level set here and at least have a rough agreement on some semantics here. So I will propose that there are roughly two types of bridging we're talking about right now, like in the industry. We have what I'm just going to call a mint and lock, and I know we can disagree a little bit on like mint lock versus like burn mint, whatever, right? But what I will say is like you have an origin chain, and you are going to take some asset and you are going to lock and or burn that asset, and you are going to mint some synthetic asset on a destination chain. In the case of a rollup, that asset may not be synthetic, it may be like the enshrined asset. And we're generally in agreement, like there are various trust mechanisms on how you could do that, right? You could do an optimistic bridge, which has the delay on a withdrawal. You could do what I would call like a committee style bridge, right? Where you have some kind of validator attestation committee that is presumably doing some kind of signature aggregation. That is their attestation to the destination side, right? So that is like one category of bridges, and then we have intent bridges, which I think, I will argue, right, that are more accurately called like a credit protocol, and that they are not actually creating new synthetic assets on the other side, right? They are simply a market maker or a solver, right, who is saying, I hold inventory on both sides of the chain. I have some mechanism of rebalancing that out of band, and then when a user wants to send to a destination chain, right, they will essentially pay the solver on the origin side, and they will then be paid generally via essentially an EOA transaction on the destination side. Are we all generally okay with those definitions of the types of bridging here?
I mean, I would say like, what about like the early generation of bridges where there's like you lock liquidity on both sides, and that's how you unlock. Like the,
Can you give like a specific
wormholes of today?
I get it, but like wormhole, if I go to bridge from one side, right, I'm locking in like a wormhole contract on like an origin chain, and then like wormhole is essentially the custodian of that via that. That is like a form of like an attestation, right? You could call it like an oracle and a message passing bridge, where there's the oracle used very generally. There's someone making an attestation of you have custodied some asset on the origin side, thus it is valid to either issue or mint or whatever an asset on the receive side.
I think the complexity that explanation belies is the fact that there's a difference between natively issued assets and wrapped assets. And mint lock bridge, sorry, it would be lock unlock or wrap unwrap bridges, and mint burn bridges have very different designs and security properties depending on if you're talking about native assets or wrapped assets. Specifically on L2s, this is very, very relevant.
Yeah, my general view is that when we do like a burn and mint, that is generally only in the context of like L2s generally. So like coming from like a Cosmos or like IBC or whatever kind of space, where I think Union, I am just broadly going to generalize you into the IBC space. I know there are nuanced differences there. We're generally, right, we are wrapping an asset or like minting a synthetic asset, right? And I think there's the more common case in that the other case is essentially in rollups, where the rollups kind of give more importance to a given type of asset, right?
I think at Union at least want to do several methods, like the intense bridging one you mentioned, but also the omni-chain fungible tokens, which is more like having native tokens. But also we want to have the option of the... Hello. Yes, I'm back again. Also we want to have the first option that you said, just the wrapped version. Basically we want to offer all the options, so it's not like IBC only offers one, like we offer multiple options there.
Right. I guess the thing I am trying to get kind of clarity on, so we can kind of progress through like the questions here, right, is that like if you want to, for example, if I want to have like ETH on Solana, I cannot do that if only an intent bridge exists, because there is no way in which a market maker satisfying this could have ETH on Solana. There must exist some form of synthetic ETH on Solana, right? And so there is, to some degree, some mechanism of like rebalancing that must occur to satisfy an intent bridge, right? And if we're like, that's just like the broad kind of like starting point. And then the other thing that is relevant to like this specific panel that we want to kind of get into a little bit is where pre-commits come into this, pre-confs come into this, right? Via something like mev commit. And so in this design, right, what kind of the things we have to do, right, if we're like a solver, is you have to say, okay, I have to prove to my solver, market maker, whatever, right, for an intent bridge that I have given them an asset on an origin side. And a pre-conf may give them an opportunity to say, okay, you can get that commitment earlier, thus you can unlock the funds on the destination side earlier. It's like a lower risk to like the solver. That is essentially the level setting. Are we generally kind of okay with that?
Yeah, I mean, I think if the point of the conversation is to talk about intent bridges, we can say intent bridges plus all of the other bridges. And so I think that's what we're trying to say. So
yeah, I'm mostly trying to
it's not that all the other bridges are the same. It's that we want to talk about intent bridges. So for the sake of the conversation, we're just going to assume that all the other bridges are the same.
Yes, exactly. The idea is that there is a relatively binary distinction between what an intent bridge can do and what it cannot do versus all of the other bridges, right?
For the panel's progression of questions.
Right, yes. Okay. All right, so going into the actual kind of questions here, so thank you. Again, we can see why Interop is a complicated discussed topic, right? So first question, right, and I'm just going to like let this to like, just kind of jump in here and we'll try to balance it out as we go here. How much do you guys think users care about transaction speed, right? And so again, that's where kind of intents come in, but also, various of you are working on different bridging technologies which may provide a faster versus like a, versus like a slower kind of like ability to do that with different trust assumptions. And then related to that, maybe a more specific question is like, do you see evidence of like what I'd call like asymptote? So we've all used like a bridge, or like, for example, if you use like a CCTP on like ETH, it's like 18 minutes. There is a sense of anxiety when you have burned an asset and you are waiting in the order of minutes, and that is like an anxiety-inducing thing, whereas you might not necessarily care between 10 seconds and 2 seconds or something like that, but that is the rough question. So we'll just go whoever wants to take it.
Funny story, so when in May 2022, Terra was collapsing in front of everyone's eyes, I had a ton of UST on Terra, and you can't really sell that anywhere. So what do you have to do? You have to get that UST back to Ethereum and sell it on Uniswap. And that transaction for me took more than 3 hours, during which UST went from like say 97 to 82 cents. And that was like, I was like freaking the fuck out. So yeah, like the faster the better. And like that is an anomaly I hope no one has to go through. But how fast? Like that's a good question.
I would say by and large, users care about speed and cost and don't care about security for bridging. That's why when we see where the majority of demand is accruing for bridges. They're generally like trust me bridges or very small committee-based bridges instead of the large number of very complex and intellectually interesting bridge designs.
And I guess the question might be then, what is the trade-off space? And again, what are the asymptotes, right? If they care about both speed and cost, I think we can all generally, there's some level of trade-off space there, right? Yeah. And maybe it intersects with security. Does anyone have opinions on kind of like what is the like preference for a user? When are they willing to pay more? For example, in the like Terra case, right? People were generally aware of like, yeah, you're willing to pay a premium to get out, right? If we look in like a meme coin space, it's not necessarily bridging, right? But very obviously people are like, oh, they pay 2% slippage on the bot. And they're like, no one cares about 2% slippage if they see the candle wicking down, right?
Well, they don't care about security until a bridge hack happens. And then all of a sudden everyone cares about security again. And then it fades away until a new hack happens. And that's at least why at Union we prioritize the security part with our CKP-based bridging. But we also see that that alone is not enough. So people really care about speed. And I think last year we estimated that we would do around 1-2 minute transfers, but then fully trustless, CKP-based. But we also saw that that was not good enough. So we made quite some massive improvements from our side to lower that down to 8 seconds now with proving. But we still see that things like intent bridging can beat that time. And that's why we also want to offer that kind of speed, because people don't always care about security, but it's nice to have it as a separate option, I think.
But if you think about it, the user is not taking any risk in an intent bridge. All of the risk lies with the relayer. So it kind of gives you the fast bridging, no risk for the user. Obviously, the solver needs to price that in, but like from a user perspective, it seems like it is as good as it can get.
It can be a bit more expensive.
It's more expensive because you have to pay the cost of capital and the adjusted risk of the asset declining in value.
True. Yeah, but like I guess what I'm trying to say is, do you have a, for example, benchmark on how rates on across, say, differ from something like, I know mentally that makes sense, but like is it like large enough? Because do people even care about it? Technically, yeah, but like, do people even care about it?
Well, the question is also about whether or not we're talking main routes or long tail routes, right? Bridging ETH between ETH and optimism or ETH and base is going to have a massive amount of liquidity on both sides and a very low capital cost and risk. It's a little bit different if we're talking about bridging, an OFT style token on layer 0, where you want to move, I think Pengu is an OFT token, and you want to move Pengu onto Sofon L2, which is a somewhat, very exciting directional project, but a little earlier stage than base.
I think users in general start to look at security when they're trading size, and if that's not the case, then you should just go to something like Across, get it done in a couple of seconds, not even a problem. Across can't even do size, right? So I think just when it comes to security, I think most users, from our experience, what we've seen is if your trading volume is like $1,000, 4-digit, 5-digit numbers and things like that, they really don't care so much. But you're absolutely right, I think, in terms of your point about how intents just move all risk upstream. It's for sophisticated actors to be able to kind of price that risk.
But I think your point is right. Like the asset class and the size of trading really changes the equation.
And I guess, so within that, right, it's very obviously like intent bridges are going to be like bounded by liquidity, right, like any other market, right? It's somewhat also bounded by, we'll call it like rebalancing speed, right? Where like intent bridges came out of, they weren't called intent bridges at the time, right? But like they originated out of these like fast path bridges on like optimistic roll-ups, right? Where the assumption was the only path for the asset was a 7-day withdrawal period. And therefore this was also right before the L2s had centralized exchange like integrations, right? So your only way as a solver or whatever market maker you want to call was to rebalance every 7 days. That obviously has implications on the ability for that person to manage inventory based on how one side of that inventory goes, right? Does anyone here feel like they have kind of confidence in numbers we might be looking at again, we don't want to get like overly specific, but like naively, $10,000 is often used as the number where below that amount, people will do intents. I'm not sure who proposed that first number, but I've heard that a lot this week already, right? Does anyone feel like they actually have kind of information on, maybe you like Arcana are like, okay, we see or our routing is seeing it's going through an intent, and then once it hits 15,000, actually the intents start to run out of liquidity very rapidly for like meeting those orders, and then you go to a slower path bridge that is just kind of not constrained by liquidity because the send side is issuing this kind of synthetic asset on the other side. It's not kind of dependent on a marker maker.
So I think that those numbers first came about when Across got really popular. I think they started out at around 10,000. I think they would do about 50,000 worth right now. That's sort of their limit. But this could scale, like Across could scale. They can't scale right now because they can't do partial fills. But this could easily scale across, like, let's say, if you have 10 solvers who can do partial fills of 50,000 each, then it might take a bit longer, but you're still going to end up with a size trade of about 500,000, which is pretty good.
So I think like one distinction here may make sense is like in an Across kind of model, the market makers, the solver is taking the risk in the event of a reorg, right? So that has, like, when you go up high in value, you pay more for a bridge like that than say something like Stargate, because in Stargate you have liquidity locked in both ends and you can still get back in a few blocks. And then you have the canonical bridge which takes you 7 days. So I think there's a difference where larger amounts on something like Stargate is cheaper than Across. And for reference, the median Across transfer between like base and Arbitrum is around 50 to 100 USDC.
Gotcha. But generally, right, like I think like the takeaway here, like there's a variety of things, but there is some kind of, probably step function looking, but kind of a sliding scale between the size of liquidity you want to send between assets, right? And the speed at which you can do that, and then there's a trade-off in like cost there. But there's also going to be like bounding functions, right? Where if you say, hey, I'm willing to pay more money to send $100,000 across an intent bridge, that may just not be doable because there's just not a solver willing to do that, even if you're willing to pay 10 times more than their very marginal kind of like solver fee.
Yeah, we don't have data on that yet, but it would be very interesting to see what that results to.
I think, a somewhat controversial take, I think a large aspect of the bridge industry is trying to like create this picture of you could potentially lose your assets in a transfer, so you should pay more for some bespoke solution. The reality is, like, the majority of the large bridge hacks were created from locked pools of assets sitting there at rest when the contracts containing those assets were compromised. So you're sending $100,000 between two chains, and you're worried, but in reality, like, the amount of risk you face from your in-flight asset is very minimal. I mean, I can't think of a major bridge hack where that in-flight asset was compromised for some random user on some random day, right? I can think of many where the liquidity pool on one side was compromised, but it's a very different question. And so this is why I think users gravitate towards the lowest cost possible, because there really isn't a justification for why they should be paying, for these bespoke and complex security guarantees.
Yeah, I guess maybe we can move on. And that is kind of the point you were making about like a burn versus like a wrap asset, right?
Exactly.
The wrapped asset fundamentally is sitting in a liquidity pool that has the implication of like, on either side of this thing, right, they can lose the key and all that money is gone. If we look at like, I guess one question, if people have kind of views on this, otherwise we can move on, right? Intent bridges don't necessarily make that distinction. And what I mean by that is like, for certain assets, the asset you are getting on the destination side is fundamentally a wrapped asset, even if you go through intents. But if you go through something like intents on like a roll-up bridge, right, you still have like the bridge risk on like, it's controversial, but you still have like, I guess what you say, like, you can do an intent on top of an OFT, right? And
yes.
So you still, whereas if you do, for example, something like a USDC where we have like a native circle issuance, right? You only, with an intent, have it in flight because you are assuming that they are essentially rebalancing out of band via CCTP, right?
So I guess, the point that I'm making is one of the selling points of intent bridges is you don't face risk when your asset is in flight. And so my counterpoint is you generally don't face very much risk when your asset is in flight anyway.
Right, agreed.
So it makes the selling point of an intent bridge, if it's more expensive than just a trust me bridge or just a small quorum bridge, really not very compelling, because in either case you face very little risk.
Right, exactly. It's essentially percent of time that your asset is going to be at risk, and in like an intent bridge, sure, like you remove the in flight, but actually that's a marginal percent of the overall.
Exactly,
time
and that's not where hacks happen.
Yep. Okay, so moving on from there, I guess high level question. We kind of touched on something. What optimizations and techniques does your team specifically work on to improve the speed of bridging? And we can just go down the chain if we want.
So I can start. We're participating in this like intent bridge working group, and what we do is, okay, so the architecture we have is we run roll-up full nodes inside our node infrastructure. That way we can read from those roll-ups. And in the intent-based world where Alice deposits funds to an escrow contract in the origin chain, Solver pays Alice on the destination chain, you need to basically prove Solver's performance on the destination chain back to the origin chain. And today, Across does that in an optimistic method. We do that proving by TEs, and we allow the solver to get paid back in a minute instead of like a 60 minutes or 2 hours. We just like put a demo on that today. I think that's cool.
Yeah, Lagrange isn't a bridge company. We don't build bridges, but we're a ZK company, and insofar as security ever becomes a requirement on bridging, we offer technology that's relevant for those contexts.
Yeah, and that nicely ties into Union, where I think all advancements into ZKPs directly result into faster transfer times for us, given that we use ZKP provers to make safe transactions. And next to that, if you use intent bridges, you can also get faster transfers. So.
Right, so and Dom, I'll go to you. But essentially, we can think about like those two as both being like optimizations in the underlying kind of like bridge, right? Not the like credit protocol intent wrapper around it, right? And so by improving that functionality, the intent itself can be more efficient. Similar, John, to your thing, right? Where you're saying essentially you are reducing the time at which a solver has capital locked up, and therefore they can theoretically get a higher velocity of overall liquidity, right?
It's the same thing. So every bridging transfer, whether it be intent-based or whether it just be a mint-burn bridge, you require asserting the state of chain A on chain B. You either do it a priori to the user receiving their asset, which is the case in a mint-burn bridge, for example, or you do it a priori to the solver receiving back their payment. But in both cases, you have to assert the state of chain A on chain B. And so ZK is just a technology that can be used for that. TEs are a technology that can be used, and that economic guarantees are, and a bunch of other things that we develop for security paradigms can be a technology that does that. We generally see the least secure ones are the ones that are used for many reasons that we've talked about before, but you can build ones that are more secure if you have an.
Basically, better ZK is faster state verification, and therefore faster bridging.
And faster asset withdrawal for intents.
Yeah, I think it's faster asset withdrawal rather than faster bridging, because bridging, just like in the intent world, happens fast anyway.
So it would be faster bridging for a mint burn bridge, faster asset withdrawal for an intent bridge.
We have so many kinds of bridges.
And Dom, can you kind of bring us into kind of discussing preconfs a little bit? Apologies, we haven't gotten to you so far.
Yeah, the question was how do we make bridges faster? And at Interstate, we're not really in the business of bridges at all. We're just one component that can plug into any of these other companies if you want to help you make bridges faster. So we're like infrastructure companies. So I guess my answer is pass.
So for us at Arcana, we don't really look at just how to make movement of funds fast. It is the user has an intent to kind of do something. How do we make the entire thing faster? So obviously we're looking at doing a bunch of different things. So the way our system works is we don't really do smart accounts or smart contract wallets. We work directly with EOAs. So the whole point is how do you avoid a user double spending? So we collect funds on source chains, solver supplies them on destination. That's the fulfillment of the intent. That's the singular intent that we kind of work with, and that's really about it. So what we're looking to kind of do is essentially these deposits that happen, which then trigger solvers fronting liquidity. How fast can we make that sort of eventing happen? And so I think I keep saying this, precons kind of fit in well there. But also just resource locks in which you can have like some sort of credible commitment, which can then almost halve the time in which a user's intent can get fulfilled with just their EOA without needing to actually go and use smart contract wallets and things like that, which aren't where your liquidity isn't really fragmented and you don't really need any sort of unification or solving.
I think the preconfs in the intent bridging world is very, very relevant because if you can get an execution preconf that guarantees Alice's deposit on the source chain is not going to revert or reorg, then the solver who's filling Alice on the other side is taking much less risk and therefore could technically offer better pricing.
Right, for like a concrete example, right, like if you use like a cross and you want to do like an across fast bridge, sometimes they'll give you a confirmation like 1 second, and there's very obviously, if you're like sourcing on ETH, you're like, okay, the ETH block's at 12 seconds, so like, how do they do that kind of thing, right? They're obviously taking like a relatively big risk there, small risk, right? But like from a relative amount of time, they're taking, 11/12 of the total time of a block, right? And so with the pre-commit, right, you can essentially have a protocol level giving you that guarantee, and now it is not necessarily the solver taking on the risk of that. They are able to pass on that cost to, the kind of like Mev commit style, protocol level guarantee, right?
So we just made Union pre-conf aligned. So basically meaning that you can already do transfers that arrive well, they're not yet posted yet on the source chain, so they already arrive on the destination chain. And we do that via some stuff we did with the IBC stack, because we now leverage content addressable packets. And because we do that, we can basically utilize the pre-confirmation stuff, which I think is pretty cool because that ties into next to me about intent-based bridging and how to utilize also what Primev is doing.
And are you doing that only one direction? What I mean by that is, are you only getting a pre-conf on the send side? You're not necessarily giving the user a pre-conf on the receive side.
Well, for us it is only relevant, right, when someone wants to move out of ETH towards another chain, because that's where the finality is slower. And I mean, Cosmos-related chains are often having a bit of faster finality, so then it's not that relevant. But at least from Ethereum to other chains via Union, then it would be very relevant.
The problem I have is like a lot of this is a solved problem, right? So if I want to send assets from chain A to chain B and I want to have low risk, I can use almost any of the bridges that exist today that mint and burn. And my at-flight risk is very low. But because of that marginal amount of risk, we're going to build an intent network, an intent protocol, a solver network, an intent protocol, and a pre-conf protocol. And each of these is going to launch tokens. Each of these is going to raise financing and have 3 competitors. And so we've developed 9 new infrastructure companies or more to solve a problem that is really non-existent to begin with, which is the in-flight risk of your asset at the point of transfer. And so this is, I guess, part of the issue I have with pre-confs in general. It feels like solutionism.
The sell of intent-based bridging isn't really to counter in-flight risk. It is convenience. And the best solution for any sort of cross-chain actually lies upstream of all of these sorts of things. I think single slot finality, if we get to that point, then we're gold. But the problem is that you're going to have 10 working groups trying to solve interop and get to the ideal solution, and we're just not going to get users in. So our take is that we need solutions now, and intent-based bridging solves for a real problem of convenience that exists today. If I have to go and ape into a meme coin on Solana today, but all my assets are on Base and Arbitrum and Optimism, and I have to go and sit and bridge and switch contexts and all that cognitive load that I have to take, you're not going to see any new users who are going to come in and actually start doing stuff. So that's the problem that people like us are attacking and looking to solve for.
Right, but like that, if you look at trading volume for most meme coins on Solana, it's not people who are custodying their assets on Base, right? So we're like manifesting a definition of a customer profile that I would argue makes up a very small subset of people doing this.
Okay, I won't debate data, but
yeah.
But we've seen all those screenshots on Twitter of all the inflows from all the different L2s into Solana. That obviously happened. Right?
They do, yeah, they bridge over.
So it's not Solana native sole bag holders who are all aping into meme coins. It's obviously people from all these other chains who are making their way there.
Right, bridges are great. It was a comment that the cognitive load of bridging and then having your assets in Solana and swapping versus just keeping them on Base to swap into a meme coin and unswap back is something that I don't think is... Anyway.
I think more the argument would be it's not necessarily doing both directions. It's just saying, I want to go buy a meme coin. I have $50 on Solana. I have $1,000 on Base. I want to ape the meme coin for $1,000. the meme coin is going up, a lot rapidly as they do, right? I want that $1,000 there like now, and I am willing to maybe pay $50 to get that $1,000 now because the coin's going to go up like 10% if I wait, 10 seconds, 30 seconds, 60 seconds, right? And so fundamentally, intent bridges are people paying for speed, because I think we've all are generally in agreement that for better or worse, the users do not care about the security of a bridge. They will be very upset at you when you lose all their money, but until then, they really just don't care, and they're not going to understand if you explain why your bridge is more secure than others. Someone else is going to tell them that their less secure bridge is more secure than yours, and they might just have more Twitter followers, so.
I think the part I would contend is that an intent-based bridge is by definition faster than a wrap-on-wrap bridge or a mint-burn bridge. I don't think that's true. If you look at L2s on Ethereum, like for example, I believe Axler will go off one block finality on most L2s off sequencer confirmation. So you're not going to get any faster than that with an intent bridge.
That feels somewhat controversial. I'd like other people to comment on that, because my naive view, right, is that generally people, and you might see this from like a, kind of like an abstraction perspective, right, of like, what is the theoretically a user might have like a sliding scale saying how fast you want to do this, and like that's going to have an adjustment in price, and obviously that's probably not surfaced right now, right? But generally, I think the at least understanding, right, is like intent bridges are faster, and so maybe Axler is, but does Axler have a sufficient amount of liquidity or usage, or is it, more expensive even than an intent bridge that is comparably fast? And so that's going to be a trade-off between the speed of, a wrap mint bridge, right, to an intent bridge, right, trade-off against the cost, right? The intent bridges have a relatively low cost for the speed too.
Yeah, just a quick point that I wanted to make on that is, you can go and see bridging times for intent-based bridges on something like a jumper. You go, like the most common routes, go there. You'll see that the first couple of results are always relay and across, and then everyone else. And while the timing may not really be very different, like you're talking about something taking, say, 7 seconds versus 14 seconds, and it's fine. But the point is that jumper picks one, and that's the first one on their list. And I'm just a button click away from just proceeding with that option, right? So it makes a world of difference when you can be that few seconds faster, because the user who's not as discerning is just going to come and click the button.
Yeah, I think so. In XLR is to me a liquidity bridge. The reorg risk on the destination chain costs XLR money.
Exactly.
So XLR is going to wait and not release because they don't want to go out of pocket. I think on an intent bridge, the reorg risk is on a solver. Solver is in the business of like managing risk. They price that into their quote better than XLR does, and therefore I believe intent bridges are faster than XLR kind of bridges.
Disagree. The point that I'm disagreeing on is the architecture of L2s in general, which is generally what we're talking about bridging from, is already so centralized that going off of sequencer confirmations is just enough for most bridges. And most of them will just go off that. And so when I say, a lot of these teams will go off of one block finality for a roll-up, it's because, the trust and faith of the Optimism Foundation is behind that one block attestation. And so that's what they base on. And so they're willing to take the counterparty risk at a centralized level, in essence, for a lot of these bridges, which makes it to a user equivalent in speed.
True, but like L1 to L2 across use is like not negligible as well. Like that is an area where reorg is a real risk.
So moving from an L2 to Solana, or Avalanche, or where is the demand?
Like I'm talking Ethereum to base. If you do that via, say, across, like Ethereum has a reorg risk, right? Like much larger compared to an L2 or a rollup. Ethereum reorgs.
Yes.
Okay, so someone has to, let's say you go in Ethereum, Arbitrum, someone has to take that reorg risk.
So are we talking L1 preconfs or L2 preconfs? Because usually when I see preconf protocols, they're pitching me an L2 preconfs.
I guess we need better definitions, but I was thinking about L1, like what these guys are doing.
I think generally, right, when we were thinking like pre-cons, right, to kind of, Robert's point on like union, right, generally it's on the source side, and so if we're going from like ETH to a roll-up, right, it is assumption that you are getting the pre-conf on the source side, which in this case would be Ethereum. That being said, there's some trickiness in like using the roll-up as an example, because like different roll-ups have different views on how they will reorg relative to an ETH reorg, and I don't know off the top of my head what the hell that would mean
Which
for
is why
like
they go off
across, specifically off optimism, how that reorg ends up landing based on how they do the EOA, right? But I think we get the general idea, right? It's like, again, it's the risk that like the solver is going to like lose their mind. So like I'm like the founder of like Astria. We had like fundamentally we had like a bug in like one of our clients when we did like an NFT mint. We saw like demand. We had a non-determinism bug. We were using Relay as one of our bridges, and so fundamentally we did have a reorg event which actually had about $4,000 get lost because it went outbound from the chain that was inevitably reorged. And so payments were made on the source chain, they were paid out on the destination chain, but then those payments were reorged out on the source side. So this is like, again, it is like a rare mistake. We had literally a bug in our client, like it was very bad, we should not do that. But there is some amount of risk, right, of having a bug. That being said, it was still not that large. I also think like there's a question of like volume relative to time and like how long before like a reorg sees like a pause. That also might be a thing. But I guess, does anyone have, again, we're at I think 45 minutes in, so we maybe want to move to Q&A after this. Does anyone have thoughts on like when was the last time we saw a reorg of size? Has any solver actually lost money to a reorg? Okay. How much relative to like I guess what I'm trying to get is like, what are we looking here, right? Are we looking like 0.001% kind of thing, like one a year, or like what is like the cadence we're looking at from like a quantity? And is this like is there like a chain where this happened? Like a specific? Yeah. Yeah, and that's what we do, right? You can still see the thing, and you just like match it back, and you just like comp someone. Someone just takes a loss.
Yeah, I think also like we need to start thinking about it from purely the user's perspective, and not just my bridge is so fast and it's as fast and things like that. The user has fragmented liquidity. He has funds on 4 different chains, wants to transact on a 5th. We need to start factoring in the user going to different UIs, trying to bridge from chain A to E, B to E, C to E, and all of those sorts of things. And until we start doing that, I think we'll keep having these conversations over and over again. And we'll keep optimizing for the wrong things, in my opinion.
I agree. Right. I just maybe disagree that that's like a solvable problem. We can just, like how many talks this week can we just put the XKCD slide up, right? Like the XKCD standard thing. Like I will make the standard that will prevent us from fragmenting all the other standards.
Yeah, I would also say I don't necessarily think that it's better for a user to have their transfer predicated on a preconf protocol, a solver network, an intent expression language, and then a solver network. Sorry, then an intent protocol. Because there's a bunch of infrastructure dependencies that are highly opaque when the simplest solution is just having the bridge itself take the risk on a fast transfer, which is what most of them empirically are willing to do.
I think that argument sort of needs far more nuance, because I don't think we can do it here in this panel. But honestly, if you like I said, if a user needs to kind of move funds across multiple chains to one destination chain, then that you almost need to like source chain abstract it, which none of the bridges do. And that cognitive load is significant and real. And we're not going to get anywhere close to mass adoption if we say, oh no, Interop is solved, this is how you do it, go to that bridge or this aggregator, and then you figure it out there, and then things will happen.
But I will once again say I don't think we get towards mass adoption by building a bunch of infrastructure when we're seeing generally that integration of different components of the infrastructure at the company level, right? So a fast L1, a very hyper-performant L2 create a much better user experience than a bunch of fragmentation and a handful of different like wrap bag infra protocols. Like that is in fact the thesis that people are trying to now unwind from Ethereum to get back to a more integrated stack. Right? L1 gets faster. L2s become high performance. That's how you compete.
Okay, so I will throw it to the audience here. We have, I think, if I'm not off here, and if someone could check me, 10 minutes for Q&A. Maybe we have like 5 minutes. But if anyone from the audience wants to ask a question, I don't know, I will just hand them this mic. Otherwise, we can throw one more question to the panel. Yeah.
When ZK real-time proving?
Depends on the
for
definition.
Ethereum L1 blocks, 36 million.
Wait, sorry, what were you saying?
For Ethereum L1 blocks at 36 million gas, when proving it under 12 seconds.
What's the fastest benchmark now? It's like 6-7 minutes
Oh, I think it's
on
slower.
ETH.proof, right?
Yeah, I think it's 13 or something.
No, I think succinct is under that. But I would assume like 12, 18 months. Like if we're talking about like ASICs or like general purpose programmable hardware for cryptography, I think it'll be much faster.
How expensive?
I don't have the number off the top of my head. It's going to depend on the amount of gas that's used in the block. And it's going to depend on like the amount of hash functions you're doing because there's not a correlation between gas and proving cost. A direct correlation. It's a rough.
36 million, Ketchucks, no Poseidons,
That's the problem.
block
right?
171.
It's going to take forever. It's going to be
No,
expensive, right? That's why you have to change the TFM in theory, right? This guy gets it.
All right, anyone else have one? We got time for one more question. Okay, let me see what we didn't.
Could all the founders and participants on the panel maybe say a few words about like what speed means for their protocol? Like, is it even relevant for your protocol? Is it something that you care about? Is it something you're trying to optimize, or is it something that's already available in your protocol so that you kind of map that to making Ethereum fast?
Yeah, maybe I can go first there. So I think I said it before, but Union firstly not prioritize speed because we prioritized security because we saw all these bridge hacking happens. And we were like, okay, if we can do it trustless, then even if the speed is slower, then it's still good because it's trustless and you can just assume that we're doing what we're doing well. But then we also saw, like I said before, like people do really care about speed. So last couple of years, we really tried to get the architecture up and running that we can do fast proving times, way faster than the 1-2 minutes that we first aiming for. So yeah, we're now at 8 seconds per transfer, but there is a reason why we wanted the intent bridging, because you want to give that option to your users. Maybe even in an ideal world, you don't want to have it, but you just want to have your users to have multiple options that they can choose themselves which speeds they prefer. So that's why we're going for multiple options here. And even though security is our highest aim, I think speed always wins when it comes to bridging.
We don't do bridging. So for us, speed just has to do with proving time. And the speed of proving is going to be dependent on what you're proving. So there's not really like a North Star in speed for our network. I would say the North Star that we optimized for speed for is auction time, since a lot of what we do is effectively a double auction or very similar to an order book of how we assign kind of people bidding on generating proofs of people requesting proofs. And so the faster we get auction time, the closer the latency of decentralized proving is to centralized proving. So, I guess network round trips and auction time are for us important.
I mean, we deeply care. We're in the business of improving user experiences. Developers want to kind of make this happen to avoid churn of users. So for us, our North Star is very clearly instant. I click a button, it just happens. So how do you get to that point is what we deeply care about, and we're trying to do all the things we can to kind of get to that sort of place without, of course, putting users at tremendous risk. It's a trade-off, but yeah, we definitely side on the speed.
We care about proving roll-up state back to Ethereum because we use hardware for now. Like we can do it instantaneously in one ETH block. That's not an issue. And then, over time, we want to make hardware permissionless. Therefore, we need to replicate. And for us, that needs to happen within 6 seconds.
And I guess so. And again, if someone can flag me on time, I'm like, I don't know if we have like 5 minutes or no minutes. Okay. So you said instant, but then you clarified by saying within one Ethereum block, and so that is actually 12 seconds, which from every other blockchain except for like Bitcoin, I'll say, that is slower than the other chain. And so maybe that's a place where we see preconfs come in, where, okay, you can speed it up and you can have preconfs that will be faster than 12 seconds, but then that means that you have a requirement on other things that may be bounding, right? Essentially, we're shifting where the bottlenecks are. Right now, you know, on ZK proving, right? Sure, 12 seconds is like a very, very hard, you know, time constraint to hit, right? Of like actually doing like a snark or whatever in that time. For TE proofs, that seems achievable, right? In the kind of, you know, kind of Cosmos, like, you know, space, right? My understanding is Union is doing like snarks of the consensus, not necessarily snarks of the state, right? So that is achievable, right? Because it's essentially just like snarking existing signature aggregation to make it like verifiable by like Ethereum or other like not things that don't like ED 25519, right? And so that is achievable. But again, if we see preconfs come in, right, where do people see like bottlenecks happening, right? If you say, okay, now I can give you a preconf in 1 second, what of the technologies are actually now going to be bottlenecked on that are not bottlenecked at 12 seconds? And then do we see that moving more towards intents, where now we say, actually, okay, the intents become slightly more relevant again, because you can always just have a middleman willing to just like pay the risk for that, right? They have no technological limitation. They can do that all out of band, and that's on them.
Yeah, so for me, I think the main bottleneck are the reorgs, but we already talked about that. And for Union at least, it's only relevant from going from Ethereum to other networks. And we already see with our just recently deployed test network that people are complaining that Union is slow the moment they want to transfer out of Ethereum, because users don't understand how finality works. So they expect, yeah, you say Union is fast, I want to transfer from Union to Stargaze, to Babylon, whatsoever, but it's slow, that we need to wait, because they don't understand that finality takes time on Ethereum. And that's, for me, where preconfirmations really come in handy, where you can really utilize them. But yeah, then the only downside is the reorgs, which I don't know how often that happens. So that's some kind of risk profile you need to have. But I think it's really great if you have that option for your users.
And so at Union, is it accurate to say that you essentially, you are roughly measuring the unacceptable risk of like any reorg? So you run your system saying like, we wait for like full finality of like whatever, that's like 12, 15, 18 minutes or whatever, and you're not trying to do any kind of probabilistic pricing of saying, okay, we assume we're going to send the things even if we think, okay, the risk of a reorg is like 0.01% and we're okay with that risk. You're not even bothering doing the risk modeling. You're just saying we're only going to accept, you know, full finality.
Yeah, I think we have some standards for that, but basically we want to shift that risk to the solver. So that's the, at least because we want to use preconfirmations only within intense bridging, and then that risk for the reorganization only comes to the solvers, like we were already saying here. So
right. So that was maybe my last question, I guess, is like in that context of you saying we're going to wait for full finality, right? A preconf still has some amount of risk of like a reorg, right? And like presumably, depending on how the preconf is designed, right, there may be like a significant penalty to the validator for like reneging on like a preconf they gave, but theoretically it is possible, right?
Yeah.
And so you are also seeing that as, we're just going to say that's up to an intent person. And so maybe that rolls an intent, but you as, how are you going to categorize your bridge, right? But like not an intent bridge are still not going to take on preconf risk and see that as acceptable.
Yeah, that could definitely be an option, yeah, definitely.
I just want to kind of maybe interject there, saying we have reorg-resistant preconfs on Mev commit.
Oh, that's great. That's great.
So the way it works is because you get commitments from all block builders, even if the chain reorgs, the same block builders build the same block with the same transaction, and so you're basically like, you know, you can move forward without having to care about reorgs, and they happen about 1 to 2% of the time, which is about 70 to 80 blocks a day. So they're quite risky on.
Well, that's great, and we should definitely talk further about that.
This is pretty in the weeds, Murat, but is there any risks that like theoretically, right, all the proposers could just be like, I don't like that the builders are giving these preconfs, I'm going to take back my power, I'm now just going to start censoring builders. Obviously, that's like a pretty nuclear option, but I'm assuming you've thought about that, and are you just saying like that is like not kind of like, that's like an assumed like functionally 0% risk?
Yeah, so the good thing about what we've done with what we call insured commitments is that the insurance doesn't just come from the proposer's amount, that the block builder also has a stake. So when you're like, let's say you're Union and there's a 100 ETH transaction, right now it supports up to 10 ETH, but let's say like, okay, 10 ETH. You can put up 10 ETH in your insurance request so that even if the proposer reneges or whatever happens, the block bills that committed to it will have to kind of pay that. So you're kind of guaranteed crypto economically, even though the transaction might not go through. Now we want to kind of improve this over time by like adding some sort of underwriter who can like optimize these, but right now that's how it works.
Okay, I think we are at time here. Thank you to all the panelists.
Thank you, everyone.
Thank you.
Thanks, Josh.
Thank you all.